My previous video was a collection of 3D printed projects. This is number 5 from that video. A 3D printed dual link disc 2-stage cycloidal gearbox with a NEMA17 stepper motor. It has a 272:1 reduction ratio with 16 on the first stage and 17 on the second stage. The two inner discs are bolted together and the two outer discs are bolted via a standoff. This design came about from a viewer asking if it was possible to reduce the number of bearings in the gearbox. My single stage cycloidal gearboxes typically have about 30 bearings. This one has 5 small bearings and 2 large bearings. It is definitely not back drivable and the backlash is about 1 degree, which isn't great. It is not held on both sides like my other gearboxes, but it does have 2 large joint bearings and it is a good rigid connection. I haven't applied any grease and I have not pushed the system too hard. It can easily lift 2 kilograms at 300 millimeters using 24 volts at 5 amp. I have made a similar design using 56:1 reduction ratio using 7 and 8 stage ratios. It had poor pressure angles. I will try this again with a larger eccentric distance. The design is nearly statically and dynamically balanced. The rotation is not completely linear and it has a slight retrograde action. Thanks Dan for the tip on the clip. The assembly is quite easy, but the order of operations is important. The following is detailed assembly instructions, with some more testing at the end.